Hello, I am Esther,
And I'm Catherine.
and our project is on the least frequently used eviction algorithm for BaseJump STL.
So the goal of our project is to develop a least frequently used algorithm for integrating into BaseJump STL and replacing the current least recently used algorithm for cache eviction. And there's a need for this because LRU, while it's area efficient, it might not always be the best choice for performance, and especially when data access patterns exhibit like a higher frequency of access in certain areas of the cache. Our approach is to combine least frequency used and least recently used algorithms, switching based on the observed access patterns in order to improve cache hit rate while also maintaining efficiency.
So, some things to know is that cache replacement algorithms, they manage caches by evicting data to make room for new or more relevant information. And eviction algorithms are those that prioritize data based on recency or frequency of use. Some common algorithms include LRU, the least recently used, LFU, the least frequently used, and FIFO, first in, first out. And our focus for this project will be on implementing the LFU algorithm and also creating a control scheme for switching between LFU and LRU.
So our overall system design, we are basing a little bit off of this paper that we found called a novel adaptive replacement policy with combining LRU and LFU policies, having both of these policies controlling one cache. So each cache block has an R value for how recently used and an F value for how frequently used, and then it's controlled by a cache manager. Our design contains the LFU and LRU modules separately, and then they switch based on the current miss rate and also aiming to improve the hit rate. Yeah.
So this will be the general flow of our design. On the left, it's whenever a new request is made, then you ask the module whether this newly requested data exists in the cache or not. And if it does, then you increment the hit count. And if not, then you increment the miss count. So then on the right, you see the flow of our control logic, which is we have this signal called switch that keeps track of which algorithm we're using right now. So if switch is 0, that means we're currently using LFU and vice versa. And whichever one we're in, we evaluate the current miss rate and compare it with a threshold miss rate. And if the current miss rate is greater, then we switch to the other algorithm and resets the hit and miss count.
So this is just a project timeline for the milestones that we want to get to throughout our project. So we want to be able to get to a minimum viable product of creating our LFU module. So we want to be able to write the RTL and make a test bench and be able to integrate it into BaseJump STL by week 1. Then we want to map out our algorithm for the usage case between LFU and LRU on BaseJump STL, and then testing that with BaseJump and pushing it through the whole design flow through synthesis, PAR, DRC, and LBS. And then we want to be able to integrate LFU and LRU into one module and then be able to have them switch based on the current miss rate. Then we would want to test with BaseJump and then push it through the design flow again. And after that, we want to analyze some performance metrics like power, performance, and area. And then we also want to optimize maybe the switching algorithm. And in a possible goal we have is to be able to set dueling, and hopefully possible by the end of the quarter is to be able to stage a pull request and merge it into BaseJump.
So the expected results are that this hybrid LFU and LRU unit will outperform the standalone LRU unit in BaseJump STL. And this is by evaluating the metrics such as total hits, total misses, and hence hit rate and miss rate. And this is our project. Thank you.
Thank you.